Okay, continuing from yesterday's lesson, or previous lesson, here is another type of exponential equation. These are called logarithmic scales, and you'll see them the Richter scale, the decibel scale, and the pH scale. Basically, this means that these things grow so quickly we're using a power of 10. You'll notice here there's no base, so this is a base 10. So for example, if you hear someone say there was an earthquake that had a magnitude of 6, and then the next day someone says there was a magnitude of 7, this means that it was 10 times as powerful. Okay, this 1 in the increase of the Richter scale actually means that it was 10 times as powerful. So we're going to talk about how that works in a logarithmic scale. So here's the example of the Richter scale formula. The magnitude of an earthquake is the log comparing the intensity of the earthquake, and that is the S is for how much a standard earthquake is. Now this is kind of a weird formula because I don't know what a standard earthquake is, and that makes it kind of feel a little bit odd when you're doing this. Okay, so that's the formula. Let's try a question. Oh, and as I said, an increase of 1 in the logarithmic scale actually means it's 10 times as powerful. Okay, so let's take a look at one here. It says the most intense earthquake ever recorded was in Chile in 1960, and it had a magnitude of 9.5. Calculate the intensity of the earthquake in terms of the standard earthquake. Okay, so let's write the formula down. It says M is the log of the intensity over the standard intensity. So we're supposed to calculate I. Okay, we're given the magnitude is 9.5, and we're supposed to isolate this for I. Okay, now if you remember solving an equation with one log, you change to exponential form. Now it's not written, but we have to know this is a base 10. So I can write 10 to the power of 9.5 equals I over S. And if I want to get I by itself, I'm going to multiply both sides by S. So what this means is the intensity of that earthquake is 10 to the power of 9.5 times as strong as a standard earthquake, whatever that might be. Now 10 to the power of 9.5 is a pretty big number. Okay, if you were to put that in your calculator, it turns out to be something like 3 billion. Okay, now you don't need to write that out. Normally you're going to keep these as powers because the numbers get kind of crazy. Okay, so that's your answer, even though it feels like we really haven't solved anything. Okay, so how many times as intense of an earthquake was the Chile earthquake compared to the Haiti earthquake? The Haiti earthquake had a magnitude of 7, so let's quickly figure out what its intensity was. Okay, now you can see this is an example. You probably wouldn't have been able to do this if you hadn't seen one done before, but now these questions are actually pretty simple. There's not much math to them. Okay, and so if I now would go base 10, so this is 10 to the power of 7 equals I over S, and so the intensity of this earthquake is 10 to the power of 7 times S. Okay, and now we're supposed to compare these two intensities. How many more times intense was the Chile earthquake? Okay, so let's take the Chile earthquake and compare it to the Haiti earthquake. Okay, now if you simplify this, S divided by S, no problem there. And then what do we do with these exponents? If we subtract 9.5, take away 7, you end up with 10 to the 2.5. 10 to the power of 2.5 is 316.228. This means that the Chile earthquake was 316 times as intense as the Haiti earthquake. Okay? So you can see even though it's just 2.5 times as intense on the scale, it actually means something quite a bit different. Okay, so that's the end of the word problems. I gave you the homework yesterday. Hopefully the ones that you weren't able to do, you will now be able to do. Okay? So we'll finish up the log unit with the next lesson.